Hi, good morning or good evening, wherever it is that you are, and welcome to 24 Hours of PASS Cross-Platform SQL Server Management. We're excited you could join us today for Manikantan and Hitesh's session, SQL Server Management, Taming Infrastructure and Application Usage. This 24 Hours of PASS event consists of 24 consecutive live webinars delivered by expert speakers from the PASS community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when the recordings are available. My name is Ree Irish. I run the Women in Technology virtual group for PASS. I'm a Microsoft MVP on the data platform, and I'm very pleased that they asked me to be a moderator today. I do have a few introductory slides before I hand things over to Mani. Mani, if you could advance the slide. So if you require technical assistance, please type out your question into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any question throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I will read your question aloud to the speakers. You are able to zoom in on the presentation content at any time by using the zoom button located on the top of your presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. This will pop up after the webinar ends in your web browser. Mani, if you could advance the slide. So thank you to our presenting sponsors, Microsoft, Quest, Idera, and SentryOne, and also to our supporting sponsor, Redgate. The staging of 24 Hours of PASS would not be possible without their generous support. They are the reason this event is available free of charge. If you would like to learn more about our sponsors, sign up for information on how they can help you, please visit the sponsor page associated with the 24 Hours of PASS website. Next slide, Mani. PASS Summit is the PASS community's flagship event, and it is happening November 6th through 9th in Seattle, Washington. PASS Summit is the largest conference for technical professionals who leverage the Microsoft Data Platform, so immerse yourself in deep dive technical sessions, learn best practices, and discover new tips and tricks. For more information and to register, visit passsummit.com. Now, go ahead and advance the slide, Mani. So our first speaker today is Manikantan Madhunapantula, and I probably butchered that just a little bit. I tried, so I'll apologize. He's a principal engineer at Arcesium. He designs, architects, and implements highly scalable, performant, and cost-effective solutions for most complex post-trade processing requirements. He has a deep expertise in building cloud solutions, migrating on-premises infrastructure to cloud, software development, and architecture. He's passionate about learning and sharing his learning with the community. He is also the leader of the Hyderabad SQL Server User Group and is a regular speaker at local events. Hitesh Chauhan is technical lead at Arcesium. He has been working with databases for around 6 years and has worked on Oracle, MySQL, and SQL Server. In the past, he worked with Microsoft as a technical advisor for the SQL Server Engine, Performance, and Azure team. He currently works with Arcesium as a technical lead. So the next slide, Mani. And without further ado, here's Mani and Hitesh with SQL Server Management, Taming Infrastructure, and Application Usage. And Mani, it is all yours. You are good to go.
Thanks, Lee. That was quite an introduction. Ladies and gentlemen, good morning, good afternoon, and good evening. Bill Gates said, a simple idea can drive great change. In today's session, we want to cover 3 simple ideas. The first one is to understand utilization of CPU, disk, and other system resources with the intention to save some money. The second idea is to understand application utilization of these system resources with the goal to eventually optimize user experience. And the last one is to explore opportunities for proactive performance optimization and troubleshooting, something that we all love to do. This session will be a demo-focused session. I will cover the analysis of system resource utilization. Hitesh will cover application utilization of system resources. Finally, we will explain how to use this to drive proactive performance optimization and troubleshooting. For performance engineers, it's very critical to understand utilization and ensure that there is no saturation. Given the rate of cloud adoption, it is all the more important to understand utilization. Unlike on-prem, we can now upsize, downsize relatively easily based on utilization with significant cost savings. Brent Ozer, Paul Randall, Steve Jones, Rob Farley, Grant Ritchie, Aaron, the list goes on. I want to thank you all and the wonderful SQL community in general, and also for coming up with multiple ways to capture performance data. Say using Perfmon in Windows or SAR reports in Linux. I'm not going to cover that in this session. However, assuming that we have the performance data, I want to share a method to create simple and powerful visualizations to understand utilization. I want to emphasize the fact that A, this is simple, B, this is free, and C, this is something that you can do in your environment right after the session. Feel free to reach out on my Facebook ID if you have any issues while implementing this, and we'll be more than happy to support you. So let's start with a glimpse of what it would look like. At the end of the session, you will be able to quantify system utilization like this. I want to talk a bit about this graph. This is a CPU utilization graph, obviously generated with fake data. So now, the important thing to note here is, this graph tells me that 13% of the time, CPU utilization is below 20%. And if you look at the top of the graph, it tells me 30% of the time, the system is above 80% utilization. This is a great opportunity for SQL performance engineers to optimize the system. With this glimpse, for the benefit of all, I want to spend a quick minute to talk about one way to capture performance counters in Windows. All we need to do is use getCounter method. It takes a computer name, that's the computer on which you want to capture the data. You can pass on a list of counters that you're interested in. You can give the sampling interval, and then you can also provide the number of samples that you want. All I'm trying to say in this slide is it is that simple to collect performance data. In the reference section at the end of this presentation, we've included a number of references which will talk about collecting Perfmon data. Now, assuming that we have this Perfmon data, I want to start a quick demo to see how to use this. So, for the purpose of this demo, I have generated random data using norm.img, an Excel function. The only disclaimer here, you can use everything else in the presentation, but please do not use this random number method to generate reports for management. With that disclaimer, I'm moving on. So the number that you're seeing here that's highlighted, 45, that's a sample of CPU utilization. Here it is 39. Like that, we have lots of samples. This is the data that comes from perfmon. Now, to make sense of this information, we will have to bucket this information. So this is basic high school math, wherein we try to create a histogram or frequency distribution of the samples. So for the purpose of this demo, I want to create 5 buckets. As you can see here, we have 20, 40, 60, 80, and 100. You can create the buckets that you want. In Excel, we have something called Analysis Toolpack. I'm hitting on File, and then I'm selecting Options. And in Options, I'm moving on to Add-ins. In Add-ins, I'm selecting Analysis Toolpack. And then I'm saying OK. Once this is done, in your Data tab, at the extreme right, you will see Data Analysis Wizard. So to generate a histogram, we'll quickly select the Data Analysis Wizard. It has amazing statistical functions. We're not covering all of this. In this session, we'll focus on the histogram. So we've selected the histogram here. We click OK, and then we try and get the input range. This is the CPU sample data. So we've selected our data. Now we need to give the bin range. Scrolling up. Now I've selected my bins. Now I'm going to say OK. So this will generate a frequency distribution. This tells me that for the data that I have, 13 samples are within 20% range. 13 samples are within 20 to 40. 12 samples are within 40 to 60. Now to make sense of this, I want to generate percentage numbers. So I'm using basic Excel magic to generate the percentage. And we are done. Now let me drag and drop to make sure that we get these numbers right. I'm still fixing the formula. Give me one more minute. Here we go. So now this is the percentage distribution. Copying it. I'm pasting values. I'm trying to graph this data. I'm doing a transpose because I like to see values in a horizontal fashion. And I'm done with that. Let's say this is data for Jan. Now I'm selecting this data. I go to Insert. I go to Charts. And then I select the stacked column chart. Now, to make sense of the data, I'm going to switch rows and columns. So this is now data for Jan. And to increase readability, I'm going to add data labels. So with this being done, for the random number data that we've generated, this tells me that 25% of the time, the system is within 20% of CPU utilization. Moving on, again between 20 and 40%, we have another 25% of the time. I want to move to the top quadrant, where it tells me that 28% of the time, the system is above 80% of CPU utilization. This is a great opportunity for us to tune things. Now, looking at this graph in isolation might not make great sense. Let's move forward. Let's assume that I've collected this data for over months. And I'm going to cheat here and copy data from an older distribution. I'm pasting the data here and I'm deleting this graph. I'm again trying to draw the same graph. I go to insert, I select charts, I select the stacked. I'm going to switch rows and columns. This chart tells me how data is across months. I'm just trying to focus on the chart so that you all can see it. So in this chart, in Jan, 19% of the time, the system is within 20%. Now fast forward to July, we see that 40% of the time, the system is within 20% of utilization. Likewise, in Jan, 29% of the time, the system is above 80%. In July, it's only 10%. So while the stacked bar chart is great, in order to further simplify things, we can also choose a percentage that is convenient for us. So in here, I've chosen two numbers, greater than 60 and less than 60. If you look at the formula, all I'm doing is summing up the values that are greater than 60 and the values that are less than 60. And I'm just verifying that we're 100. Now this graph, I just plotted with the data that's greater than 60. This clearly tells me while the system has been deteriorating from Jan till April, because in Jan, it's just 56% of the time the system is above 60%, whereas in April, 85% of the time the system is above 60% utilization. Now here comes the interesting part. In April, we are attending 24 hours of PASS. We are upgrading our skills and we are all charged up to do performance tuning. So we go back and we implement and do performance tuning. And in July, we see that the utilization has come down drastically and we've made a significant difference. I guess the central idea with all of this that we're trying to introduce here is we can now systematically generate data, go to management, give them an idea of how the system is being utilized and how can we do it with simple tools. This is not only about CPU. Just imagine that our friendly SAN administrator did a great upgrade to the disk system and he tells us the disk is not a bottleneck anymore. This will be a scientific way to measure all the data, plot, graph, and then look how things are changing over time. Now that we talked about performance optimizations and tuning, I want to hand over the next set of slides to Hitesh, who will be talk about XUNs and using application data. Hitesh, all yours now.
Thank you, Mani. Thanks for that. Hello, everybody. Good morning, good afternoon, good evening, based on wherever you have joined from. My name is Hitesh, and I'm going to cover the second part of the session. So that would be based on the extended events. So let me quickly go to that slide. Okay. So first of all, like, what will we cover in this? We are going to cover how to set up extended events via GUI T-SQL. I'm not going to go a lot deeper in that because extended events have been around for a while. So I know that a lot of people might already know how to do this. Second part, capturing and loading data into a table. This is where I want to spend a little bit of time on. What I want to do is I want to capture intensive queries, infra-intensive queries, as in queries that take a lot of logical reads or physical reads, or if run for greater than X amount of time, right? Those kind of queries, capture them and have automation of sort that loads them in a table, right? Third that we want to cover is aggregation on top of this for trending. So why are we doing all this? Like, why to capture this data? What will we really gain out of this? So there are three things that we really want out of this. One, we want to have baseline data. For example, if tomorrow one of my developers comes and says my queries are running slow, yesterday it ran really slow as compared to last week, we should have absolute data to say that, okay, it has run slow. Yes. If it has run slow, what has it done? How many physical reads? How many logical reads? Did it spend more time on the CPU, or what exactly did the query do? That is one. Second that we want to have is we want to capture timeouts and long running queries. Like mostly we like either depend on a third party tool, or we depend on like the application owners or the developers to give us the queries that are timing out, or we have some sort of auditing. So like that's where it will be helpful. And third is we want to have or probably create an API or something that we can give to the developers, and they can use this data and see how their queries have been performing. So this last point that I've mentioned, aggregation on top of the data, that's where we will aggregate per user, per program, how that user has been using the infrastructure. For example, user X has been using month over month, probably in the first month it did 10,000 logical reads. In next month, it did 20,000, 30,000. So we should be able to establish a trend of sort. So that's what we are planning to do with this. Moving on to the next slide. Before we start with the demos, I want to share some best practices for using extended events. So the first one would be the event loss. So when we set up an extended event, we do not want to set no event loss, because that causes SQL Server not to drop any events in case of any kind of pressure on memory, which eventually like impacts the performance. We should use causality equal to on track causality. That helps us correlate events. We are going to see this. For example, if I have a procedure that has 10 queries, I want to figure out like what procedure did this query ran as a part of, or what queries ran as a part of this procedure. I should be able to tell that, so that we can build up a story around it. Third is do not use expensive events. For example, show plan is one. Definitely. Actions, there are some actions that are really costly. For example, call stack is one of them for sure. You can use them while troubleshooting and you know exactly what you're doing, but don't do them for what I'm trying to show you, like have a baseline and have trends and stuff like that. So let's jump to the first demo. What are we going to see in this? I am assuming that most of us have done extended events in some sort. So we will quickly run through how to set up extended events, what events I have chosen, and why I have chosen them and why not the other one. There is one that I have deliberately left out so that I can answer like the difference between that one and the one that I've chosen. Okay. And second is like how can we relate extended events to profiler trace? Because we have been using profiler trace for a while, right? And we know how profiler trace works. So I want a way by which I can correlate, okay, SP colon statement completed, where does it map in extended events? So that there is a table, there is a key mapping table that we can use. So let's jump right to it. So let me open SSMS. So I have set up a couple of databases here. One is AdventureWorks, one is monitoring data. So this is kind of a centralized database that we want to use. So when we capture any kind of data, right, we have a centralized monitoring server from where we capture all the data and push it to a centralized database so that we can, most of us are not supporting one instance or one server, right? We have a lot of servers. So we want to have a mechanism by which I can run a script on my centralized server. It should get the data from all the servers, the extended event data, do all sorts of data munging and push it to a table on my centralized server. So that's what this guy is. The monitoring data is that database. I'm going to start my agent. Okay, now let's start with seeing the setup of extended events via GUI. Okay, so management extended events. Like I already have a session that I have set up, but I'll quickly run through and show how did I do that. So I do a new Session wizard. I choose a name, for example, anything. There are a couple of templates available, but we are not going to use that because we will get our own events. So let's start with SP statement completed. So I want any statement that runs as part of procedure to be captured. So we will get SP statement completed. Then we get SQL batch completed. Why are we getting SQL batch completed? Because SQL Server actually treats, even if you run a single statement, it treats it as a batch. So like a batch with a single statement. So if we have SQL batch completed, it essentially does the job of both. Third one is RPC completed. This is mostly for procedure calls and RPC calls. Now, this is where the fun part is. I told you guys, right? I have left an event behind in the setup that I have done. That is module end. So usually it is recommended that you have RPC completed and module end both. I'll tell you why, because if you read the description for this guy, right, it says end of module execution, right? So a module can be a procedure. So the difference between the RPC completed and the module end is that if I do, for example, a RPC, let us say I do SP underscore execute SQL and I run a stored proc as part of that, that will come as a module for SQL Server. That won't come as a remote procedure call. So for that purpose, you should have RPC completed as well. Now there are some cases, like there are some corner cases. For example, if you have or your application are using UDFs, then SP statement completed, you might want to check its performance and how it's behaving on your system before you do it. Okay. Now we're moving on. There are some actions that we can set. For example, client host name, client PID. This will help you. Like for example, tomorrow your developer comes and says that, see this, I have a process that ran slow yesterday. So it'll be easier if he can give us a process ID from his side. And if we are collecting client PID, we'll be able to easily query the table that we're going to load all this in, right? So like there are some events that you can select and then you do next, next and finish. So that way we'll be able to set up a session. Now I have set up this app resource consumption section. So let's look at some of the interesting things in here. So I go to events, I go to configure. Now, if you see, we have client tab name, client host name. Like I have set up a bunch of things that I think will be useful. One of the key things that I wanted to show you is the scheduler ID. I am capturing scheduler ID. Okay. Why am I capturing a scheduler ID? Like Mani mentioned earlier, right? You have performance data. If you have scheduler ID as well, you can know and you can correlate the performance data with your extended events data. So this becomes a little critical. Now you can leave a bunch of fields out which are there, but you might not really want them. So you can select any of the events. For example, I have selected RPC completed. So I select RPC completed. Then I go to event fields. So I have unselected already the data stream, the output parameters, and the statement. Why have I like unselected the statement? Because in global actions, I have SQL text. So I am capturing SQL text, so I don't want that because that will be duplicate data. And two things that we really care about when we collect this kind of data at a regular interval, right? It will be collected all the time. Two things that we really care about is one, how is it impacting the system? So that is for us to measure. Like I told you, the SP statement completed, you might want to use it with a little caution if you have UDFs in your system. Other thing that we care about is how much data is it generating. So there are two ways for it. One, I can be proactive and like not have collect duplicate data. Like for example, I am not collecting the statement here, or in SQL batch completed, I'm not collecting the batch text, right? Second thing that we can do is, you see here on the left hand side, there is data storage. Okay, you go to event file, like I am putting everything to an event file. Here, I have said maximum file size is 2 GB. So each of the file that it generates is 2 GB. And I have set the maximum number of files to be 5. So like in SQL Trace, we have a concept of rollover. We have a similar concept in extended events. So we can do rollover. So it will generate 2 GB 5 files. Once it overcomes that, like once it runs out of that, it will not generate any more files, but rather go to the first one and write the data again to that one, overwrite that data. So this one I want you to be a little cognizant of when you set it up. there is something called multiple event loss, single event loss, and no event loss. I like even SQL Server recommends, if you see here, right, no event loss not recommended unless you really know what you're doing. You have a multi-core system and you have set up the memory accordingly. Memory as in this one, you see this one, memory partition mode. So it's node per CPU or per node, right? So if I have multiple cores, if I have multiple nodes, then I can allocate 4 MB of memory for each node or for each CPU based on what I want, and I can increase the memory also. But if you're going by default settings, don't have no event loss. It can, in extreme corner cases, result in performance deterioration. Okay, so this is what I have set up, right? So till now we have set up the extended events and we know that our data is getting collected. Now the second step that we want is all this data will come in XEL files, right? So I want to have that data in a table so that I can write some intelligent stuff on top of that. I can write APIs on top of that that I can give to my developers. They can use that table. I can do aggregation. I can create dashboards on top of that. For example, per user aggregation, per program aggregation, or trend of a particular program, like how this program has been faring for last month. Let us say your developer did a release last Saturday, and all of a sudden the entire infrastructure is running slow, or that particular program is running slow. If you have this data, it will be helpful for you to really understand what is going on with the system. So next step would be to load this data into a table. Now, there are multiple ways. I am going to use a PowerShell script to load the data. I'll quickly run through you that script, like what am I doing as part of that script. So I love Notepad++, so we're going to use that. So the bunch of variables I have said. So what does the script does? And we are going to upload the script so that you can use it. What the script basically does is it stops the set. So it has multiple functions. Okay, and then it has like a simple try catch where we are doing a bunch of tests. Okay, so what we do as part of this is first we stop the session. We copy over everything from that location, for example, a remote computer location, which we have to keep consistent. And then we start the session. Then we do the loading. Then we keep the files that have been loaded right after it is loaded into a table, the file name into a table, so that even if you rerun the script for a particular file, it should not reload the data. So we have all the infrastructure in place so that you don't duplicate the data. Now I'll quickly show you. It's a pretty straightforward SQL that we run to do this. So we are creating tables here, indexes. So we're creating tables, we're creating indexes. Yeah, it's nothing but XML parsing that we're doing. So there is a function that we can use, this one. The function name is fnxe file target read file. And what we do is in a folder, we keep all the files and run through each of the files one by one and load them, and then load in a table so that we have the data. So if I run this script, it will load the data in a table called resource utilization. So I have already loaded that data in the table. So let me show you how that looks like. So we will use monitoring data, which is our centralized database where we store all the data. So let me do a select star. Okay. So once you run that PowerShell script on your XCL, right, it will collect data from all your servers, whatever server names you have in the inventory, and load the data in a table, in this case, resource utilization, in this format. Now I have all the information that I need in this to understand my infrastructure, understand my applications usage of the infrastructure. Okay. So now let's take examples one by one. Okay. For example, if I want to know what queries have timed out, so I have a little OneNote that where I have written this small query. So all I'm doing is I'm getting like all the data, and so there are around timeout, right? There are two things. One is run status that I have been using, And second is event pairing. A lot of people use event pairing for getting timeouts. Event pairing is nothing but it looks for a start event and an end event, and if an end event is not there for a particular event, then what it says is because there is no end event, that's why this must have timed out or errored out, right? But as extended events are maturing, like there is a column that I found is run status that you can use to figure out. So there are two things: one is abort and one is error. So if my application has sent abort, if it's application timeout, right, it will send a kill command to the server, the abort command. So there will be a run status called abort. If my connection broke, or if the server where I'm doing this restarted or anything, it will be error because there will be no handshake. So another one would be error. So if I run this guy, I know what queries have timed out. For example, this is one query that timed out. I know how many seconds they ran. Okay. From where they ran, what is the machine name, what is the client name, how much CPU time it took, how many physical reads it did, logical reads it did, writes, and what scheduler was it running on. So I have all the information. There is more information, but I have filtered it out. For example, like you could know the username and stuff like that as well. So this is how we can get timeouts. Where this will be useful, you can create dashboards, like you can have the data getting collected, and you can create dashboards which says what queries have timed out in last 1 hour, and you can just put there on top of your table. In our case, there's a view I've created, but you can use the direct table. I can give you that example here. So it will give the same data. The view is just with it no log. So you can have a dashboard on top of it and say, in last 1 hour, these are the queries that timed out. Next thing that comes to my mind that like we as a DBAs really want is long running queries or queries that ran a lot, right? So all we do is we do order by duration descending. So I'll copy this second query. Now the duration is in microseconds, so I have divided it by like 10 to the power 6, and I run this, and I know these are the queries. This is ordered by duration. So this is the query that ran for 941 seconds. This guy ran for 112 seconds, so on and so forth. This is all test data, so like it might not be as good as you expect, but like when you have this on production data, this will be really helpful. Another thing that I want is I was talking about causality, right? We want causality tracking to be on. So how will I do that? So in extended events, let us go back here, right? Go to properties. You see here causality tracking. This is enabled. Okay. I can disable or enable it based on when I am doing this. Okay. Like when I'm setting up the extended events. What it gives me an extra field. What extra field? So let's look at that. So I actually ran a proc and captured its data to show you. In interest of time, I'm not going to rerun and load the data, but let's see. Let's just run this first. So it gives me all the data that is captured. So it gives me a field that is activity ID and event sequence. So in the parsing logic that we have written, we have put it in two separate fields. So I will share the script to do this. Okay. So each activity ID has an event sequence. Event sequence are nothing but how many of events have run as part of that activity. Okay. So in our case, if there is a procedure, the event sequence has to be more than one because there will be more queries. So activity ID, this one, right, is an example of one such activity ID where I ran a proc called test underscore proc. Okay, so let's run this guy. So here, what do I see here? Let's go to the right first. So you see these event sequence. So this is the order in which the queries got executed. For example, this is the first one, second one, third one, fourth one, fifth one, and sixth one. Now let's see what queries were they. So these are the queries that they ran. 6.1 is the summation. So it gives me, this is the proc that I ran. I just ran execute test underscore proc, and that proc had all these 5 queries. So this way I can actually figure out these things. Like if there is a proc if user is saying that I have a proc that runs like this, so I know that what query is run as part of what proc. If I can get the proc call and the activity ID, I can tell everything that ran as part of that proc. So this is this. Another thing, so till now we have done okay, we have baseline data, we are collecting everything. What about the API that we want to give to the end user? So we can create a view on top of this with no-lock and give access to our developers, and they can explore this data as they like and probably see how their queries are performing, for example, based on client app names or program names. Uh, like if I want to know how my query has been performing logical reads wise, right? So we capture logical reads. So we give where app name equal to ABC and order by logical read descending. So it will give me how my query has been performing for logical reads and stuff like that, or duration or physical reads, and so on and so forth. The last thing that I want to cover apart from all this is aggregation. So we talked about that we can aggregate the data, right? So what do we mean by aggregation? So I want to show basically two things, like have aggregation at user level and aggregation at program level. You can aggregate on as many levels as you want. For example, you can do at a query hash level or a query plan level to know how often my query plans have changed or for what time what query plans have been used. But for the purpose of this demo, I have wrote a small procedure which is already here, which gives me aggregation at a user level and at a program level. So I'll just show you the run for this. So these are the tables where, so this is the proc, resource usage aggregation. I'm running it for analysis type per program and analysis type per user. And I'm giving the date range for which I want to do the aggregation. What is this aggregation that I'm talking about? So let's look at the data and understand what I'm talking. So on 25th, right? See, like SQL agent generic refresher, how many logical reads it did. So if I had multiple days of worth of data, right, I could have just filtered on SQL management or .NET data provider, right? So what I would have done is I would have done where client tab name equal to, and I would have just copied it directly from here. And that would have given me across days these parameters for this particular client app name, right? Similarly, for a user, if I want to know if one particular user is killing my system, I could have done that at a user level. So for example, Hitesh, right? So I do where server principal name equal to Hitesh. So if I had multiple days worth of data, I would have got this. And then you can use Grafana or DataZen to like have this query run as part of DataZen or Grafana, where you can just show, you can give drop downs where you get the distinct users from this table or distinct program from this, and people can just see how their programs has been performing in a particular aspect across time. Okay, so where is all this standing? Like it is, and why are we doing all this? So we discussed that, but why, like what is the end benefit? We have proactive data. We can we can give the API to you, the developers, or we can ourselves tell the user, see, after your last release, this particular program, its trend has gone down, it is using more physical reads, which means it is killing the system. So you must have done something wrong. Look at it. These are the queries because we have query level data. These are the queries causing this. So please look at that. And we can open tickets for a change with the developers. So that would definitely help us, right? So the last part, which I am going to hand over to Mani to cover, is this is all the data that we have. We have perform data and we have this data. How can we correlate these two guys? Like for the perform data that Mani talked about, we have an automation that loads it to a table. So I'll just give you a quick example of the table that we have that is called performance counters. So that script that Mani talked about, right, that loads data in this fashion in a particular table called performance counters. So I have this table called performance counters. I have the other table called resource utilization. How can I make sense of this and everything? I think I'll hand over Mani for that part.
Thanks, Satish. So, like we said at the beginning, the whole idea is to see how can we make sense of the performance data and the application resource utilization to bring about a change. So let's assume that based on the resource utilization, we figure that 80% of the time our system is running above 80% of the CPU. Then, given that we're storing this information in performance counters table, it'll be a simple select to identify the time spots during which this is happening. Once we have the time information, we can very well query resource utilization and figure out what is running at the time. So the how part of the story, how the system is behaving, we can figure out through the performance counters, and what to fix is something that can come from resource utilization. Now, the interesting aspect for all of this to make sense as a whole, right? We not only want to focus on just the individual counters, but the overall health of the system. Now, again, why is this important? In a cloud-based environment, it's not only CPU. All system resources decide if we have to use or stay on the same machine or if we need an upsize. So even though we are not really capped on CPU, there might be situations where the network throughput offered by the machine is not sufficient for the workload that we are running. So if we can create a dashboard which can show the CPU utilization, the disk utilization, the memory performance, the network performance, that will give a comprehensive picture on how the system is running. And that can help us make decisions. And given the flexibility of upsizing and downsizing, that's something that we can really use to make a difference. That's all I have for today. With this, I'll open up the session for Ree.
Thank you, Mani. If you'll go back to the slide deck, please.
Sure.
So, and then let me advance mine just a couple. So the slide deck will be made available yesterday, and the slide a couple back has all of the references that they make during their session. Hitesh and Mani, I do have a few questions for you. One of them was, how often do you collect CPU? And this question was one of the first ones that came. So this was during Mani's section. How often do you collect CPU info?
It really depends on your system, but Perfmon in Windows is an amazing tool in the sense that even on heavily used systems, it doesn't really spike up the CPU that much. So to make sense, we can start with 5 minutes. If that's not helping us, then we can bring it down to 1 minute. I guess I want to emphasize the importance of taking an iterative approach here. So we start with a number like 5 minutes to get a sense of the system. And once we identify, like say we want to fine tune something, so the 5-minute sample is not really helping, then we will go down to 1 minute. And with 1 minute on a heavily loaded system, we've definitely seen no real performance impact. I hope that answers the question.
I think so. Thank you very much. Hitesh, we had numerous people ask where the scripts you used would be made available. the PowerShell scripts, the data collection, capture,
Yeah, so
things like that. Will those be made available, or are they available somewhere on the web?
I mean, we will make them available on GitHub, and we will share those with you so that you can like pass them on so that it can help as much people as possible.
You'll share them with me
Yeah,
specifically, or okay.
we'll share them with the deck. So yeah,
Okay, they'll go in the slide deck.
yeah,
References to them.
true.
Okay, good.
Just
Uh, so we'll need to make
sorry.
sure that we get an updated slide deck to Elizabeth. What were you about to say?
Yeah, I just wanted to note that while we've used Excel to collect the data, it's very much possible to write scripts to do that. All the scripts that we've used in this session will be made available on GitHub, and we will share the link in the references section of this demo.
Okay, thank you very much. Let's see. Does the data collection capture the actual parameters used in the query, or just the SQL text?
So yeah, so that's a tricky one. So the thing is, if you have dynamic queries, right, those parameters are not captured. But let us say you have a proc execution. For example, I had that execute test underscore HC. Let us say if I had parameters to it, I had given at the rate p1 equal to something, that would be captured. Although in the latest versions, extended events has come up with the output parameters. I'm yet to test those, but like from whatever I'm reading, I think that capability has come. I hope that
Okay.
answers the question.
Okay, I've asked them if that answered their question. So we'll see. Thank you.
Okay.
And toward one of the slides, about midway through, you stressed drop events, not performance, and avoid no event loss. Can you elaborate on that just a little bit? Exactly what you mean?
So let me quickly share that particular piece. So if you see here, right, let me stop this session. So if you see here, there's no event loss, right? So even in SSMS itself, it shows not recommended. The reason it shows not recommended is like for all this data to be captured, it gets captured in memory and it gets returned to disk. So here's the maximum dispatch latency. In this case, it is 30 seconds, right? So if you say no event loss, right? And in 30 seconds, we get a lot of data. Before, let us say in 10 seconds itself, the size is 4 MB, so it gets filled up, right? And if you have no event loss, that can lead to performance issues on the instance because it will eat up more memory. Okay, that's why you should tune this. If you have a multi-core system, right? If you have multiple nodes or multiple CPUs, you should select whatever you have so that whatever memory size you're setting here, for example, I've set it 4 MB. Let us say I want to set it to something else, right? 5 or 10 or whatever. That memory, that much memory size will be per node, right? That's why like it is not recommended to have a no event loss unless you're really sure. Because I am okay to lose a couple of events rather than causing performance issues on production box because I selected no event loss. Does that answer the question?
I think so. Thank you very much.
Yep.
And I had a couple of people ask how to get in touch with Hitesh. You shared, it's in the slide deck, your Twitter handle. Is there an email address that you would be willing to share, Hitesh?
Sure. So let me send it to you. Okay.
Okay, he's going to send it to me in the chat. Um, can you go back once? Well, hold on. Let me get to the right page. Sorry. Can you go forward one slide for me, Monty?
Sure.
Okay. So while he is sending me, so his email address is his name, which is Hitesh Chauhan. It's HITESHCHOUHAN, the number 90, @gmail.com. Thank you.
Thank you.
Now, we actually have just a couple of minutes left, so if you have any other questions, now's the time to get those in. Coming up next, SQL Server 2017 on Linux is the next session in the 24 hours of PASS. We'd love it if you could attend that one too. And right before we reach the top of the hour, this session is going to abruptly end. And the moderator will take care of that. And then you'll be free to join whichever one you want to next. Hitesh or Mani, is there anything that you wanted to add? We don't have any additional questions at this point.
Thanks, Ree. I think we're good.
Good.
Thank you, everybody, for joining. Thanks, Reeve. Thanks for your time.
Okay, and can you, Mani, before we go, click back up to the references slide that you've mentioned. It's like 3 up.
Sure.
And then we'll just leave that on the screen for a few minutes. People wanted the ability to see that. I realize they can't copy and paste the link, but maybe it gives them a direction that they need to go. So for those of you that attended and are still on today, thank you so much for being here. Don't forget, PASS Summit is coming up in November. If you haven't gone before, it is the most amazing thing. Not just the sessions that you get to attend, but the networking aspect of PASS is something that's really amazing. And I will take this moment to plug virtual chapters. If you're attending this, you're already a member of PASS. You can log on to the PASS portal. On the left-hand side from your profile, you'll see My Chapters. There are virtual groups that meet just about every day of the week on so many different topics, from performance tuning to traditional DBA functions, PowerShell, so many different things. And you can attend free training just like this at your desk during your lunch. Most of the sessions are recorded, so you have the opportunity to watch those that have previously happened. So if you don't already take advantage of virtual groups and you like 24 hours of PASS, you should do that. Give it a shot. I think you'll enjoy it.